Mars is the fourth planet and the furthest terrestrial planet from the Sun. The reddish color of its surface is due to finely grained iron oxide dust in the soil, giving it the nickname, the Red Planet. Mars's radius is second smallest among the planets in the Solar System at 3,389.5 kilometers. The Martian dichotomy is visible on the surface. On average, the terrain on Mars's northern hemisphere is flatter and lower than its southern hemisphere. Mars has a thin atmosphere made primarily of carbon dioxide and two irregularly shaped natural satellites. Geologically, Mars is fairly active, with dust devils sweeping across the landscape and Marsquakes trembling underneath the ground. The surface of Mars hosts a large shield volcano and one of the largest canyons in the Solar System. Mars's significant orbital eccentricity and axial tilt cause large seasonal changes to the polar ice cap's coverage and temperature swings between -110 degrees Celsius to 35 degrees Celsius on the surface. A Martian solar day is equal to 24.5 hours and a Martian solar year is equal to 1.88 Earth years. Like the other planets in the Solar System, Mars was formed approximately 4.5 billion years ago. During the Noachian period from about 4.1 to 3.7 billion years ago, Mars's surface was marked by meteor impacts, valley formation, erosion, and the possible presence of water oceans. The Hesperian period from 3.7 to 3.2 to 2 billion years ago was dominated by widespread volcanic activity and flooding that carved immense outflow channels. The Amazonian period, which continues to the present, was marked by the wind's influence on geological processes. It is unknown whether life has ever existed on Mars. Mars is among the brightest objects in Earth's sky, and thus has been known from the ancient times. Its high-contrast albedo features make it a common subject for viewing with a telescope. Since the late 20th century, Mars has been explored by uncrewed spacecraft and rovers, with the first flyby by the Mariner 4 probe in 1965, the first Mars orbiter by the Mars 2 probe in 1971, and the first landing by Viking 1 in 1976. As of 2023, there are at least 11 active probes orbiting Mars or at the Martian surface. Currently, Mars is an attractive target for the first future interplanetary human missions. Scientists have theorized that during the Solar System's formation, Mars was created as the result of a random process of runaway accretion of material from the protoplanetary disk that orbited the Sun. Mars has many distinctive chemical features caused by its position in the Solar System. Elements with comparatively low boiling points, such as chlorine, phosphorus, and sulfur, are much more common on Mars than Earth. These elements were probably pushed outward by the young Sun's energetic solar wind. After the formation of the planets, all were subjected to the so-called late heavy bombardment. About 60% of the surface of Mars shows a record of impacts from that era, whereas much of the remaining surface is probably underlain by immense impact basins caused by those events. There is evidence of an enormous impact basin in the northern hemisphere of Mars, spanning 10,600 by 8,500 kilometers, or roughly 4 times the size of the Moon's south pole, Aitken Basin, the largest impact basin yet discovered. This theory suggests that Mars was struck by a Pluto-sized body about 4 billion years ago. The event, thought to be the cause of the Martian hemispheric dichotomy, created the smooth borealis basin that covers 40% of the planet. Mars is approximately half the diameter of Earth, with a surface area only slightly less than the total area of Earth's dry land. Mars is less dense than Earth, having about 15% of Earth's volume and 11% of Earth's mass, resulting in about 38% of Earth's surface gravity. The red-orange appearance of the Martian surface is caused by ferric oxide, or rust. It can look like butterscotch. Other common surface colors include golden, brown, tan, and greenish, depending on the minerals present. Like Earth, Mars has differentiated into a dense metallic core overlaid by less dense materials. Current models of its interior imply a core consisting primarily of iron and nickel with about 16 to 17% sulfur. This iron sulfide core is thought to be twice as rich in lighter elements as Earth's. The core is surrounded by a silicate mantle that formed many of the tectonic and volcanic features on the planet, but it appears to be dormant. Besides silicon and oxygen, the most abundant elements in the Martian crust are iron, magnesium, aluminium, calcium, and potassium. The average thickness of the planet's crust is about 50 kilometers, with a maximum thickness of 125 kilometers. Mars is seismically active. In 2019, it was reported that InSight, now offline, had detected and recorded over 450 Marsquakes and related events. In 2021, it was reported that based on 11 low-frequency Marsquakes detected by the InSight lander, the core of Mars was indeed liquid and had a radius of about 1830 plus or minus 40 kilometers and a temperature around 1900 to 2000 K. The Martian core radius is abnormally large, accounting for more than half the radius of Mars and about half the size of the Earth's core. To this, it has been suggested that the core contains some amount of lighter elements like oxygen and hydrogen in addition to the iron-nickel alloy and about 15% of sulfur. The core of Mars is overlaid by the rocky mantle, which does not seem to have a thermally insulating layer analogous to the Earth's lower mantle. The Martian mantle appears to be solid down to the depth of about 500 kilometers, where the low-velocity zone, partially melted asthenosphere, begins. Below the asthenosphere, the velocity of seismic waves starts to grow again. And at the depth of about 1,050 kilometers lies the boundary of the transition zone extending down to the core. Mars is a terrestrial planet with a surface that consists of minerals containing silicon and oxygen, metals, and other elements that typically make up rock. The Martian surface is primarily composed of thol-IITIC basalt, although parts are more silica-rich than typical basalt and may be similar to andesitic rocks on Earth, or silica glass. Regions of low albedo suggest concentrations of plagioclase feldspar, with northern low albedo regions displaying higher than normal concentrations of sheet silicates and high silicon glass. Parts of the southern highlands include detectable amounts of high calcium pyroxenes. Localized concentrations of hematite and olivine have been found. Much of the surface is deeply covered by finely grained iron oxide dust. Although Mars has no evidence of a structured global magnetic field, observations show that parts of the planet's crust have been magnetized, suggesting that alternating polarity reversals of its dipole field have occurred in the past. This paleomagnetism of magnetically susceptible minerals is similar to the alternating bands found on Earth's ocean floors. One theory, published in 1999 and re-examined in October 2005, is that these bands suggest plate tectonic activity on Mars 4 billion years ago, before the planetary dynamo ceased to function. The Phoenix lander returned data showing Martian soil to be slightly alkaline and containing elements such as magnesium, sodium, potassium, and chlorine. These nutrients are found in soils on Earth. They are necessary for growth of plants. Experiments performed by the lander showed that the Martian soil has a basic pH of 7.7 and contains 0.6% of the salt perchlorate, concentrations that are toxic to humans. Streaks are common across Mars, and new ones appear frequently on steep slopes of craters, troughs, and valleys. The streaks are dark at first and get lighter with age. The streaks can start in a tiny area, then spread out for hundreds of meters. They have been seen to follow the edges of boulders and other obstacles in their path. The commonly accepted theories include that they are dark underlying layers of soil revealed after avalanches of bright dust or dust devils. Several other explanations have been put forward, including those that involve water or even the growth of organisms. Radiation levels on the surface are on average 0.64 millisieverts of radiation per day, and significantly less than the radiation of 1.84 millisieverts per day or 22 millirads per day during the flight to and from Mars. For comparison, the radiation levels in low Earth orbit, where Earth's space stations orbit, are around 0.5 millisieverts of radiation per day. Hellas Planitia has the lowest surface radiation at about 0.342 millisieverts per day, featuring lava tubes southwest of Hadriacus Mons with potentially levels as low as 0.064 millisieverts per day. Although better remembered for mapping the Moon, Johann Heinrich Madler and Wilhelm Beer were the first areographers. They began by establishing that most of Mars's surface features were permanent and by more precisely determining the planet's rotation period. In 1840, Madler combined 10 years of observations and drew the first map of Mars. Features on Mars are named from a variety of sources. Albedo features are named for classical mythology. Craters larger than roughly 50 kilometers are named for deceased scientists and writers and others who have contributed to the study of Mars. Smaller craters are named for towns and villages of the world with populations of less than 100,000. Large valleys are named for the word Mars or star in various languages. Smaller valleys are named for rivers. Large albedo features retain many of the older names but are often updated to reflect new knowledge of the nature of the features. The paler plains covered with dust and sand rich in reddish iron oxides were once thought of as Martian continents, and given names like Arabia Terra or Amazonas Planitia. The dark features were thought to be seas, hence their names Mare Erythraeum, Mare Cyrenum, and Aurora Sinus. The largest dark feature seen from Earth is Syrtis Major Planum. The permanent northern polar ice cap is named Planum Boreum. The southern cap is called Planum Australe. Mars's equator is defined by its rotation, but the location of its prime meridian was specified, as was Earth's, by choice of an arbitrary point. Madler and Beer selected a line for their first maps of Mars in 1830. After the spacecraft Mariner 9 provided extensive imagery of Mars in 1972, a small crater, located in the Sinus Meridiani, was chosen by Merton Davies, Harold Mussorgsky, and Gerard de Vaucouleurs for the definition of 0.0 degrees longitude to coincide with the original selection. Because Mars has no oceans and hence no sea level, a zero-elevation surface had to be selected as a reference level. This is called the areoid of Mars, analogous to the terrestrial geoid. Zero altitude was defined by the height at which there is 610.5 of atmospheric pressure. This pressure corresponds to the triple point of water, and it is about 0.6% of the sea level surface pressure on Earth. For mapping purposes, the United States Geological Survey divides the surface of Mars into 30 cartographic quadrangles, each named for a classical albedo feature it contains. In April 2023, the New York Times reported an updated global map of Mars based on images from the HOPE spacecraft. A related, but much more detailed, global Mars map was released by NASA on the 16th of April 2023. The vast upland region Tharsis contains several extinct volcanoes, which include the shield volcano Olympus Mons. The edifice is over 600 kilometers wide. Because the mountain is so large, with complex structure at its edges, giving a definite height to it is difficult. Its local relief, from the foot of the cliffs which form its northwest margin to its peak, is over 21 kilometers, a little over twice the height of Mauna Kea as measured from its base on the ocean floor. The total elevation change from the plains of Amazonas Planitia, over 1,000 kilometers to the northwest, to the summit approaches 26 kilometers, roughly 3 times the height of Mount Everest, which in comparison stands at just over 8.8 kilometers consequent.